Hi everyone and welcome to A-Level Revision with MFS. In this video, we're just going to be going over some exam questions related to thermodynamics. Now this video is specific for AQA and these exam questions have been taken from past AQA exams. So our first question states, state the meaning of the term enthalpy change. Now this is a key definition that you just need to be aware of, and there are many definitions that you get taught, but there's a simple definition that the mark scheme wants. So if I just show you what the mark scheme wants here, this is the definition that you will see on most mark schemes: heat change at a constant pressure. Okay, that's just enthalpy change. It's just something that you need to learn. Heat change at a constant pressure. Now, the second part of this question says the figure below shows an incomplete Born-Haber cycle for the formation of calcium chloride. Okay, so we've got calcium chloride here at the bottom, and we can see that there's an arrow pointing towards it. So that means calcium chloride is being formed because the arrow is pointing towards it. And we have to fill in the gaps which are on this Born-Haber cycle, and we have to write down the formulas and include the state symbols. Now, with Born-Haber cycles, there's just a simple process that you have to go around. This cycle, it's one of those Hess cycle types that you saw back at AS level. This is just like the A-level version of it. Now, calcium chloride. First of all, how is calcium chloride formed? So we've got calcium and we're going to add Cl2. Now Cl2 is a gas and calcium is a solid. So that's what's really happening here. Calcium is reacting with chlorine to form calcium chloride. Okay, and this is enthalpy change of formation. Now, if we look at the next stage, what's happening is it shows you that calcium is changing from a solid to a gas. That tells you that calcium is being atomized. So that's what we call the enthalpy change of atomization. And then from then, we see that calcium has now lost one of its electrons. That's the first ionization energy of calcium. So if you cast your minds back to AS level, you would have gone over ionization energies, and that's basically what's happening here. So it's the first ionization energy of calcium. Okay. Now, as you can see, our next step is blank, but because we know that calcium is in group 2, we must know that it undergoes 2 ionization energies. So now what's going to happen is that calcium, which is Ca originally plus, is now going to lose another electron to have a full outer shell. So it's going to be Ca2 plus, and it's going to release 2 electrons, and we're still going to have Cl2 gas here. Now, calcium is a gas because it's been atomized. So this is the enthalpy change of ionization, but it's the second ionization of calcium. Now, what's happening over here? So we've got chlorine. The thing that's changed is the chlorine. So Cl2 has now become 2Cl. That tells you that chlorine has now been atomized. So it's delta H, a atomization of chlorine. Now in our final step, I'm just going to show you the answers. In our final stage over here, Ca2 plus 2 electrons plus 2Cl gas. What's going to happen is that chlorine is now going to accept these 2 electrons and it's going to have a negative charge. Okay, and that's what we call the enthalpy change of electron affinity. Okay, chlorine is going to gain those 2 electrons. So now we're going to be left with Ca2 plus, and because the chlorine has accepted those 2 electrons, it's going to be 2Cl minus. Okay, and remember, we're dealing with gases here. So this is going to be a gas, and this is going to be a gas as well. Okay, and that's how you would answer this question. I've done a bit more explanation there just so you know how we've got to the answers. Okay, and here is the mark schemes for the question. As you can see, it's just really wanting your sort of formulas with state symbols, and each blank gives you 1 mark. Okay, now often with these Born-Haber cycle questions, once you've done the Born-Haber cycle, you almost always get a follow-up calculation. And this time, here's the calculation. You're given a table and you need to work out what one of these arrows is normally worth. Okay, actually I've forgotten an arrow over here. This arrow, sort of from calcium chloride solid to what we've ended with, is known as the enthalpy change of lattice dissociation. So enthalpy change of lat dissociation. Okay. If the arrow was going the other way, it would be enthalpy change of lattice association. Okay. Anyways, moving to the next part of the question, it says use figure in part A and the data in table 1 to calculate a value for the enthalpy of lattice dissociation of calcium chloride. Okay, so we're given the formation, we're given the atomization, we're given the ionization energy, we're given the second ionization energy, atomization of chlorine, and electron affinity of chlorine. Now, the key part to remember here is that chlorine, as you can see, we have 2 atoms of chlorine. Because we have 2 atoms of chlorine, any stage of this which has chlorine present, something's happening to the chlorine, you multiply the value for chlorine here by 2. Okay? So what we are trying to work out is the lattice dissociation. This is what we are trying to work out. Now, in order to work this out, we need to go this way of the Hess cycle and then go down. Okay, so this arrow will reverse. So the enthalpy change of formation will be negated. So we've got the enthalpy change of formation, which is this one. Because it's minus 795, that's the enthalpy change going downwards. However, we don't want the enthalpy change going downwards. We're trying to follow a cycle in order to calculate this. So we're just going to reverse this arrow. If we're reversing this arrow, we're going to change the sign in front of the negative 795. So that's just going to become 795. Okay? Next stage, it's the atomization of calcium. So the atomization of calcium is enthalpy of atomization of calcium is 193. So we're going to do add 193. Next stage is the ionization energy. First ionization energy of calcium. So the first ionization energy of calcium is 590. So we're going to add 590. Next is the second ionization energy of calcium. The second ionization energy of calcium is 1150. There we are. And next we have the atomization of chlorine. Now the atomization of chlorine is here, which is plus 121. Now because chlorine, we have 2 atoms of it, we need to multiply this by 2. That's the stage where what many people forget. Okay, so we're going to add 121 times 2. Then we are going to add the electron affinity for chlorine. So again, we need to multiply this value by 2. So we're going to add the electron affinity for chlorine, which is minus 364 times 2. Okay, now this is something we can put into our calculator to work out the enthalpy change of lattice dissociation. Okay, so just type this into your calculator. 795 add 193 add 590 add 1150 add 121 times 2 add minus 364 times 2, and that should get you an answer of 2242 kilojoules per mole. Okay, and that's your answer there, showing you the mark scheme. It's got the correct answer, and that would be worth 2 marks. Okay, it's done in a slightly different way where you have to rearrange the equation, but personally, thinking about this more practically, I thought it was just easier to do this, where you reverse the signs to work out the final answer, which you can just type into your calculator to get the final answer. Okay, so that's how you would tackle that question. Moving on, it says magnesium chloride dissolves in water. Give an equation including state symbols to represent the process that occurs when the enthalpy of solution of magnesium chloride is measured. Now the key part here is the enthalpy change of solution. Okay, because it's in solution, whenever it says solution, think about it as dissolved in water. When something's dissolved in water, it's AQ. That's the state symbols that you need. And because it's magnesium chloride, I'm just going to put the answer up here. We're starting with MgCl2, and that's a solid. And because it's dissolving in water, our state symbols are going to be AQ, AQ. And these two sort of elements in the compound are just going to separate into their constituent elements. So we've got Mg2 plus, and we've got Cl2, which goes into 2Cl minus. Okay, these are the ions. Okay, and that's just one mark. So the key part here, there's nothing much of thermodynamics to this question, apart from the fact is enthalpy of solution. But just remember that solution means dissolved in water. If something is dissolved in water, you know that it's going to have the state symbols AQ. And because it's the compound magnesium chloride is dissolving in water, and you're asked to work out the enthalpy of solution, the elements, the ions in the compound MgCl2 are just going to separate into their constituent ions. Okay, that's basically what's happening here. Now the next question is another calculation question. However, this time we are asked to use a different formula. It says use your answer to part D and the table and the data in table 2 to calculate a value for the enthalpy solution of magnesium chloride. Now you could use your answer to part D because we have the equation here, we know what ions we are working with, or you could just use this table. Now there's a formula to work out the enthalpy of solution, and that's the sum of the lattice dissociation, the enthalpy of lattice dissociation, and the sum of each of the ions' enthalpy of hydration. And remember, when you have two atoms, you multiply your value for one ion by 2. Okay, so again, the sum of the enthalpies of lattice dissociation, add the sum of the enthalpies of hydration of magnesium ions, add 2 lots of the sum of the enthalpies of hydration of the chlorine ions. Now this is because if we go back into the equation that we had, we have 2Cl minus. 2Cl minus means that we need to multiply this value by 2. Okay, so the lattice dissociation is just this value over here, which is 2493. So we've got 2493, and then we need to add the enthalpy of hydration of magnesium ions, and because there's only one magnesium ion, we can just plug that into our equation. I always like to put in brackets just so I know what's what, like that. And then because we have 2 chlorines, we need to multiply this value by 2. We have 2 chlorine ions, so we multiply the value by 2. Okay, so we're going to add 2 lots of minus 364. Okay, and typing that into our calculator is going to give us this answer, minus 155 kilojoules per mole. Okay, so the trick with this question is just learn the equation. You need to be familiar with the equation. So it's this equation that they want you to use. Okay, moving on. I think this is the last question. Yeah, so the enthalpy of hydration of calcium ions, Ca2 plus gas, is minus 1650 kilojoules per mole. Suggest why this value is less exothermic than that of magnesium 2 plus ions. Now if we look at the periodic table, we will see a trend. Now, both calcium and magnesium are from group 2 of the periodic table. That means they have the same number of electrons in the outer shell. However, magnesium is higher up in group 2 than calcium, and that's why it will have a less calcium will have a lower exothermic value than magnesium. Okay, magnesium will have a higher exothermic value. Okay, so if we look at the mark scheme again, this question, you'll know how to answer it. It's just getting familiar with the mark scheme. Okay, the calcium Ca2 plus ion is bigger. You could say that because, as we know, down group 2, the shielding increases, and therefore there's a weaker attraction between the outer shell electrons and the nucleus. Or you could have said that the calcium ion has a lower charge to size ratio. Okay, any of those two are fine. Okay, that would get you 1 mark. Okay, that would get you 1 mark, saying that the calcium ion is bigger because it's lower down the group, more shielding, lower attraction between the sort of outer shell electrons and the nucleus. Now the second mark is so what? Okay, if it's bigger, what happens? Okay, if it has a lower charge to size ratio, what's going to happen? Basically, because we're talking about the enthalpy of hydration here, we are assuming that these ions are in water. Because remember, condensation is when 2 elements react and water is removed. Hydration is using water. Okay, and we're talking about the enthalpies of hydration here. So we need to reference water in our answer. So if calcium is bigger and has a lower charge to size ratio, then that means that it's going to form a weaker bond with oxygen in the water. Remember, calcium is positive, oxygen is delta negative. So that means the bond which is formed between calcium and water is going to be weaker because there is more shielding, calcium is bigger, therefore there's going to be a weaker attraction between the calcium and the oxygen. Okay? And that's it for this video. That's our first video on some exam questions to do with thermodynamics. If you have any questions, please let me know in the comment section below. And yeah, that's it for this video. Thanks for watching. I hope you liked it. And before you go, hit the subscribe button and the notification bell.